at 0, so your domain is negative infinity to positive infinity. Your range, let me say that backwards. I think I just did. It's a domain. It's your range.
The domain is negative
Okay,
infinity to positive.
range is all positive. So range is negative infinity to positive infinity. Your domain, I did say it right. Domain is all the reals. Negative infinity to positive infinity. I'm going to stop talking. Okay, your range, or what y can equal, starts at your asymptote. All right, so your range changes. It's wherever that graph moves to. Okay, on a parent graph, where does it start? 0 to infinity. Is it closed or open 0? Open, because it can never equal 0. So it's 0 to positive infinity. All right, so that one will change. Your domain will not. Are you good? Now, when you're graphing these, you're going to have an exponential growth function. Okay, it's exponential because your exponent is a variable. Because that's a variable, so that makes it exponential. Now, the base is what tells you if it's a growth or a decay. If the base is a whole number, so when I take the absolute value of it, I get a whole number, something greater than 1, it's going to be a growth function. If I take the absolute value and it's less than 1, I'm going to have a decay function. So if I had 1/4 for my base, that's a decay. All right? If I had 5/6, less than 1, decay. But if I have 7/2, bigger than 1, growth. Understood? All right. So when we look at these, they're very simple. And I do not want to see any calculators. I would really like your brains to think. Yeah, I know. It's kind of scary. So when we're your graph test, we're going to use 2 chart. Negative 2 to 2. So when you plug in negative 2 for your x, this is, I'm going to do this one by hand just so you understand. So this is 3 to the negative 2. What's a negative exponent tell you to do to the numbers? Yeah, flip it over. So this is really 1/3 squared. What's 3 squared? 9. So my answer is 1/9. Can all of that be done in your head? Yeah. It's squared, so 3 squared is 9. Negative means it goes in the denominator. Right? What was that look for, Aaron?
I'm lost. Well, you can just ignore that one step and just say, take the numbers squared, put it in the denominator.
Yes. If they're negative. If they're positive, will they go in the denominator? No. It stays. And what's anything to the 0 power?
0.
1. You
Freshman.
1. So 0, 3 to the x, or 3 to the 0 is 1. 3 to the first is 3. 3 squared, 9. Any calculator needed here? No. Then you just graph the points. So negative 2, 1/9. You're here. Negative 1, 1/3. 0, 1. 1, 3. 2, 9. And you sketch in
Don't touch the bottom.
your exponential growth. And this, you're right, is your asymptote. Go ahead, Tom.
What? It can't touch, right?
Correct. Will it look like it's touching? Can you draw it that good? No.
Okay.
But
It sure looks like it's touching
Never
that
ever
negative
go into
4
the-
on my paper.
How do you get the points?
What is
It's
it?
touching.
The x you make up,
Yeah, dude, it's touching.
negative 2 to 2. Then you plug them into your equation. So you're plugging this into 3x. So it's 3 to the negative 2. Well, you know 3 squared is 9. Negative means it's on the
I
bottom.
have to disagree with you.
So it's 1/9. Good? Yes.
You graph.
Then we graph them in. Okay, do yours. Oh, I forgot. Domain, negative infinity to infinity. Is that ever going to change for us? No. Range is where it starts. So this one starts at 0 and goes up.
How does it start at 0?
That's why it's open.
Oh, right.
Okay? If it actually equaled 0, it'd be the closed bracket. Right?
Whatever happens like that.
No. Not in here. Okay, your turn. So graph that. Oh, I take one. So your domain's negative infinity to positive infinity. Range, 0 to positive infinity. Okay, those are parent graphs. That's as easy as they get. Does everyone understand that? Yeah. Most of the kids did. All right, the next one is exponential decay. Now, when we're decay, means it starts high and goes low. Fair enough? So it just flips. So on here, if you look at your base, they can write decay in two ways. They can write decay as a fraction. So you can see 1/3 here. That indicates decay. Or if 1/3 is on the bottom, that 3 really means what? It's negative x. So I can put it up. That's the way they usually like to write them. So on your college entrance, you're going to see this. All right? Generally, what they put in there. So if you see 1/3, our negative exponent, we have a decay function. That means it starts high, ends low. So now instead of my numbers starting really low and going high, they're going to start really high and go low.
And they're going to cross it.
And they are going to do the same thing. So now when you plug in -2, so you're plugging in -2 up here, correct? So that's 3 to the -2. Well, what's a -2? Positive 2, so that's 9. 3 squared is 9. Getting? Don't space off.
I'm watching.
They're getting a long haul after
You are getting close to being gone. All right, what did I just say?
Oh.
She's squared.
Why? 3 squared -2. No, I did not say. Okay, you're plugging in -2 up here. Pay attention. So negative times a negative is a positive, so that's really 3 squared, 9. So -1 is really to the positive 1, so it's 3. Everybody understand?
Sure.
Okay, 0 is still 1. 1/3, 1, 9. So when you graph these, -2, 9, -1, 3, here, 1/3, 1, 9. So it does the exact opposite because it is a decay function. What's my domain still going to be? Negative infinity to positive infinity. And what's my range?
0 to positive.
0 to positive
Why is
infinity.
it negative infinity?
Because okay, so this goes this way, right? And this is positive infinity. No matter what number I plug in here, I'm going to get an answer. Am I going to be able to see it?
No.
It's going to be absolutely ridiculously big. But it's still there. All right? Makes sense? It would help if I put my arrows on. But my programmer doesn't do it.
And what's after drilling?
Okay, your turn. You're doing 1/4. Yeah, you should be.
I'm done too.
Okay, check with your neighbors. Did you do your asymptote, your domain, and your range?
You do that?
Am I going to ask you on the test?
I hope so.
Oh, no. Oh, he said it will always be 0. That's not true.
Almost always.
No, it's going to move. That asymptote's going to move. It's going to go up, it's going to go down. The asymptote is going to move. The parent graphs are always 0.
Is the domain and range going to be the same?
The asymptote is 0.
Yes.
Always.
No. The domain will always be negative infinity to positive infinity.
Alright, and
The range is going to change. Because I can take that graph and move it up or move it down. And that asymptote is going to move.
But that asymptote is 0.
That asymptote is 0 because it's a parent graph. Okay? Good. All right. So this thing should have looked like. Okay, so we got 16 off my graph. 4, 1, 4, 16. Oh. Something on that order. So it goes negative infinity to positive infinity for your domain. Range 0 to infinity. Where's my asymptote?
X-axis.
X-axis.
Where do you get that from?
Where did I get what part from?
1
Asymptote is what it approaches.
0.06.
So like this guy, every number you put in, right? So if I put in 1, I got a 4th. 2 is a 16th. 3 is a
Yeah, but
64th.
you know how it dropped a lot from 16 to the 4?
Yeah.
Say that like everything's like moved up and say 1 point's at 32, 1 point's at 16 or so,
Mhm.
and then it kind of starts going on that. How do we know it doesn't drop again and then runs against the x-axis?
It won't because it is an exponential graph. It has to approach something.
Yeah,
Right.
but what if it approaches it way later on?
It won't do a huge drop of it. It'd be a gradual drop if that's true.
Ding, ding, ding. We got one.
It'll never go under zero.
Nope. Oh yeah. If I move my asymptote down, it will.
See,
It can.
So say you move your asymptote down.
Mhm.
How don't we know it's gonna drop again slightly?
You're good. All right. So let's say I move my asymptote down here.
Yeah.
Okay. When you do this graph, this point right here would be right here.
Yeah.
Okay. This point here would be here. These points are still going to follow the same pattern.
What I'm saying is like.
But they cost to zero.
I'm saying, say your asymptote's right where you have it.
Yep.
And then you graph up top. What if all of a sudden it takes a
It
jab
won't.
down?
It will not.
Okay.
Wait,
Not an
wait,
exponential.
how can it, how?
Wait.
No,
All right.
There's no way.
Oh, there is.
No.
Okay, now we're going to show you moves. It is very, very helpful to have colored pencils right now, like 5 of them.
You got them?
Hey, you got me?
I'm gonna use pens.
So you can use pencils, anything, 5 different colors.
Five?
You need 5.
Let's color in one dozen.
One can be black for pencil and pen. That gives you
I'm
2.
just gonna make one light line and one dark line. That's 2.
That's 2. You need 5 graphs.
There's 5. Actually, there's 6.
I'll do that.
Give me an orange.
That's Ken Johnson.
So,
What I like,
Yes.
very much so.
I don't know. This is great. I can't mess it up.
There's gonna be one day where you're gonna leave the.
It's not nice.
Give it to him. One day, you'll find it.
Hey, found it.
I am not a happy person.
Well, then I'm really good.
When you're up here, remember how we had A, H, and K for your parabolas and your cubes and all your graphs? That does not change. We still have A, H, and K. And they are still attached to the same places, except now they look a little different. So the A, what's the A stand for? Do you remember? Stretch, yeah. And it also told me if it stretch or compression or positive negative makes it flip, right? Okay, so the A tells you it's a stretch or compression. It also tells you if it's a reflection or not. Well, we still have an A. It's in front of your base. So when you look up here, that A is in front of your base. So when I go down here, we're going to do 2x as your parent graph. And we'll graph that in a little bit. But when you look at your A on this one, it's a -3. Why can't I say that's -6 to the x power? Because that would be wrong.
Because you said it wrong.
But why is it wrong?
Because you said it wrong.
No, that's not why.
Because wouldn't it change the exponent if you multiplied them?
Yes. Order of operations, you have to do exponents and then you had it right. Exponents before you can multiply. And since the exponent is a variable, they cannot be multiplied together. So it's going to look like two numbers beside itself, and your first instinct is to multiply them. Is that allowed? No. So this -3 here is a what? What's the negative tell you it's going to do?
Decline.
Flip it. And what's the 3 tell you it's going to do? Stretch it. So it's flipped because it's negative. It's a stretch because it's 3. So if it had said positive 1/3 there, it would have what? Compressed it. If it had a positive 3, I would have stretched but not flipped. Are we getting it? Okay, now if you look up here, we still have an x minus h, just like before. What did the h do on the parabola? Yeah, and it moved it how?
Left to right.
Left or right. So if it's a positive 2 up here, it's going to move it how? To left. It's always opposite. It's minus h. So that's going to move that whole graph to the left. Now, the k, which is behind, just like before, how did the k move the parabola? Up or down. And that's the same thing. It's going to move the whole thing up or down. So all your moves are the same, except now you're doing it with exponential graphs. Are you ready?
So
You're gonna graph all these graphs.
Oh, I need one.
Okay, now, everybody up here, we have 2x. That's going to be my parent graph. We're going to base everything off of this. So I did -4 to 4 just so you can see it. So you're going to graph this. So when I plug in -4, 2 to the 4th is 16. Negative means it's 1 over. Agreed? So we have 1/16, 1/8, 1/4, 1/2. Everybody okay? What part? You're doing just the first line. Just here.
So that's why.
So that's just
Yes.
one graph right there.
That's one graph. So that's the y. So that's a point. So we're going to graph -4, 1/16. So you're going to go down here to your graph. You're going to go -4, 1/16. Understood? -3 is 1. Okay. -2 is 1/4. Oh, I'm too high. Oh. -1 is 1/2. 0 is 1. 1 is 2. 2 is 4. 3 is 8. And I'm out of room.
What's 1, 2,
1 is 2.
2 is
2 is 4. You're squaring them. 2 squared is 4. 2 cubed is 8. Are we good? Draw in your exponential graph. Make sure you can see those points very well. Make them dark. I'm sorry, what? Well, first one doesn't matter. After that, we're going to use colors. Okay, everybody good. Okay, that's my parent graph. What's its asymptote?
0.
0. And have I moved it at all?
Nope.
So there's no move. Asymptote is 0.
Same color.
Yeah, because that goes to that graph. Okay, that's my one graph. Everything good. Okay, now we're going to do the next graph. So when we go here, -3 times 2x. So what am I going to do with every number in this column?
Flip it.
-3 times 2x. So what am I going to do with 1/16?
Times by 3.
Well, times it by a -3, so it's -3/16. Good? So now I'm going to take 1/8 and multiply it by -3. So I got -3/8. What's my next one?
-3/4.
There you go.
Ooh.
This one? -3/2. 1 times -3 is -3. -6.
-12.
And -24, which is not going to fit on my graph. Now, those points, I want you to graph in another color. So grab color.
Wait, they're going.
They're going what? What are they doing?
They're going down.
They are going down.
Like really far down.
Like really far down.
Like they're getting.
All right, so when you're here, I'm going to use red. So where we put in -4, what did we get? -3/16, so it's here.
So it's below.
When you plugged in -3, what did you get?
It's below the 0.
It's below.
Okay.
It's what? -3/8. When you plugged in -2,
-3/2.
These are all these colors.
when I plugged in -1, what did you get when you plugged in -1?
Oh, -3/2.
You told me I was for -2.
Oh, -2 is -3/4. Come on.
Oh, and I just erased them all.
Can we use actually?
Yeah, well, no, they're mine. Here, -3.
I have some news for you, mister.
All this time, he's working, so
How much inside that?
I'm just aging all the
Tyler,
time.
can you eat the office, please?
I'm your agent, Tyler, I'll start it.
We walked in.
Hey,
I was like, what is this?
Brother, be like, this is my agent.
I need to know what's the news on there.
What?
So.
Tomorrow's test, do not forget.
Like,
Go through your reviews. You better go through it. Have you? I got lots of them. I don't know, me and Tess don't agree.
exactly.
Yeah.
Doesn't matter how much I study, I still end up looking at me. Literally.
Don't freak out.
I just don't like tests in
I'll
general.
get out later. I get testing Friday bad.
Guys, I got nailed in the head with a pen. Okay, so there's, you guys know Michael, right? Michael, last name. I don't know his last name. Johnson? Yes. Okay, so he's messing with his pen. He's on clear ball, ready for it. You know where the ball is?
No.
He exposes it and he nails me with the back of that.